Okay, so the next set of theorems we will cover in properties of parallel and perpendicular lines is same side interior angles theorem and alternate exterior angles theorem. Okay, so same side interior angles theorem. This states that if a transversal intersects two parallel lines, then same side interior angles are supplementary. What does it mean to be supplementary again? Our angle pairs will equal 180 degrees. So if I'm given line L is parallel to line M, then we have the measure of angle 4 plus the measure of angle 5 equals 180 degrees, and also the measure of angle 6 plus the measure of angle 3 is equal to 180 degrees as well. Alternate exterior angles theorem states that if a transversal intersects two parallel lines, then alternate exterior angles are congruent. So if we have line L is parallel to line M, then we have angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. Now let's try some examples. We're going to be finding measures of angles by solving for x, and we also want to justify our answers by using theorems or postulates. I'm going to be focusing on 12x minus 3 and 105 degrees because I know they are corresponding angles. And our corresponding angles theorem states that they will be congruent to each other. So I have 105 degrees is equal to 12x minus 3 by corresponding angle. Now I can solve for x, which equals 9, by using my addition and division property of equality. Looking at angle 7, I know they're vertical angles, and vertical angles are congruent, so 105 degrees is equal to angle 7. Again, by vertical angles are congruent. Lastly, I want to find angle 3. And I know angle 3 is supplementary to the 12x minus 3, which is also 105 degrees. So I'll set up my equation for that. And then by the definition of supplementary angles, I was able to set it equal to 180 degrees. And by substitution and the subtraction property of equality, I get the measure of angle 3 is equal to 30 degrees. Now that was a lot of theorems to cover, so let's try some examples. We're going to be proving an angle relationship. If we're given line A is parallel to line B, we want to prove that angle 1 and angle A are supplementary. So before our proof, we would know line A is parallel to line B, and from the diagram, we also know that angle 1 and angle 5 are corresponding. Also, angle 5 and angle 8 form a linear pair, which also means that they're supplementary. So angle 1 and angle 8 are supplementary, or the measure of angle 1 plus the measure of angle 8 equals 180 degrees. Now our plan is to show that angle 1 is congruent to angle 5 and that the measure of angle 5 plus the measure of angle 8 equals 180 degrees. Then we can substitute in angle 1 and angle 5 to prove that angle 1 and angle 8 are supplementary. Okay, so here's my two-column proof here, and we'll begin with line A is parallel to line B. From here we can say that angle 1 is congruent to angle 5 because if lines are parallel, then corresponding angles are congruent. And if our angles are congruent, then we know the measure of angle 1 equals the measure of angle 5 because congruent angles have equal measures. Finally, angle 5 and angle A are supplementary because angles that form a linear pair are supplementary. The measure of angle 5 plus the measure of angle 8 equals 180 degrees by definition of supplementary angles. From here we can say that the measure of angle 1 plus the measure of angle 8 equals 180 degrees, and we just use the substitution property. Lastly, we can say angle 1 and angle 8 are supplementary, again by definition of supplementary angles. So now that we have gone through the various theorems and postulates pertaining to parallel lines cut through a transversal, take a break before we move on to perpendicular transversal theorem.